Hello, today we will learn about total internal reflection. Total internal reflection is the phenomena of reflection of light into a denser medium from an interface of this denser medium and a rarer medium. In simple words, when the light gets reflected back, when it is coming from denser medium to rarer medium, this is known as total internal reflection. I repeat, when the light is coming from denser medium and going towards the rarer medium, then at the interface of this denser medium and rarer medium, the light gets reflected back to the denser medium. We will understand this by a diagram. This is the surface. Let us say this is rarer medium and this is denser medium. Make a normal to the surface. Name this point as O and this point as A. Now, if a light is coming from point O to point, let us say A1, it will get refracted into the rarer medium. To show refraction, we will first draw normal at the point A1. Now, the light is coming from O to A1. It will now refract in this direction. It will bend away from the normal because the medium here is rarer medium. Let us take another path of light. Light is coming from O to point, let us say A2. Arrow indicates the direction of light. Make a normal at this point again, and the light will get refracted in this direction. It will bend away from the normal. At one angle, the angle of refraction will become 90 degrees. Then this angle of incidence in the rarer medium is known as critical angle. This angle and this angle are equal because they form alternative interior angles. These are two normals. Two normals will be parallel to each other. This transversal A3 is cutting these two normals. So this angle and this angle will form a pair of alternate interior angles, and alternate interior angles are equal. So these two will be the critical angle, and the angle of refraction will become 9. So the definition of critical angle is that critical angle for a pair of media in contact is the angle of incidence in the denser medium corresponding to which angle of refraction in the rarer medium here becomes 90. When angle of incidence in the denser medium, that is this angle or this angle, becomes greater than the critical angle, then the light will get reflected back into the denser medium. We will learn this with the help of a diagram. So this is the surface, this is normal to surface, the point O, point A, and this angle of incidence is greater than the critical angle. The light will get reflected back into this denser medium. This phenomenon is known as total internal reflection. Now we will apply Snell's law, and Snell's law states that product of refractive index and sine of angle of incidence or refraction at a point in a medium is constant. Here we have incident angle equal to critical angle, and the refraction will be 90 degrees. We are applying this in this diagram, this one. So the refraction angle will become 90 degrees. Let us name this medium as medium A and this as medium B. Refractive index of medium A is mu A and refractive index of medium B is mu B. Now we will apply Snell's law and this applies here. Mu B into sine C. Here the angle is C, the critical angle, is equal to mu A, that is this rarer medium, and the angle here is 90. And we know that sine 90 is equal to 1, so I am writing here 1. Now mu B upon mu A equals to sine C, or you can say mu A upon mu B is equal to 1 upon sine C. Now we can write it as mu dp equal to 1 upon sine of critical angle. And mu can be written as lambda 0 upon lambda m. This is mu. What is lambda 0? It is wavelength of light in vacuum, and lambda m is the wavelength of light in medium. So we can replace this by this. Sine C, that is equal to 1 upon mu, is equal to lambda m upon lambda 0. So the refractive index depends on lambda like this. As refractive index depends on lambda, then critical index will also depend on lambda, that is, it will be different for different wavelength of light. For example, lambda of red wavelength is greater than lambda of violet light, so the critical angle will be greater for red color than that for violet color. We will now learn about an experiment and how we can see the total internal reflection of light. For example, there is a beaker. There is soap solution in this beaker. So it is turbid. Let us shine laser through this water. When we shine laser into this beaker, it's in this way, then some part of this light will get reflected and some part will get reflected. Now, if we adjust the angle to be the critical angle, then the entire light will get internally reflected and we will see no reflected light. Okay. There are various applications of this phenomena. We will learn some of them. The first is the brilliance of a diamond. We know that a diamond shines very much, but why